Okay, number 30. I skipped over 29. I will talk about 29 in class tomorrow. I need to teach you a little bit of nuclear physics before it'll make sense. So question number 30. A billiard ball of mass 0.155 kilograms moves with a velocity of 12.5 meters per second towards a stationary billiard ball with identical mass. It strikes it and then it stops. And it wants to know, is the collision elastic? Before we can figure out if the collision is elastic, we have to find V2F. And we find V2F using conservation of momentum. So M1V1 initial plus M2V2 initial is equal to M1V1 final plus M2V2 final. Now this one's really easy because initially the first ball is at rest, so the second ball is at rest, so that term goes to 0. And after the collision, the first ball is at rest, so that goes to 0. So we have M1V1 initial is equal to M2V2 final. And we're looking for V2 final, so divide both sides by M2. So M1V1 initial divided by M2. So it's going to be 0.155 kilograms times the 12.5 meters per second. And remember, it said identical mass, so you're dividing by exactly the same mass. So really, these are just going to cancel out. We could have actually canceled them out right here. So V2F is equal to 12.5 meters per second, and that's in the original direction of the first guy. Once we have that, now we can check to see, is it elastic? So remember our equation is 1/2 M1V1 initial squared plus 1/2 M2V2 initial squared is equal to 1/2 M1V1 final squared plus 1/2 M2V2 final squared. Again, this term goes to 0 because it's stationary initially. This one goes to 0 because it's stationary finally. So 1/2 0.155 kilograms times 12.5 meters per second squared is equal to 1/2 0.155 kilograms times 12.5 meters per second squared. You might be able to predict that these are going to be equal since they're the exact same numbers on both sides. Okay, just for the record, I will never be this nice to you and give you exactly the same numbers here. Okay, for those of you that actually calculated it, you end up getting 12.109375 joules. Remember, that's what energy is measured in. 12.109375 joules. On this side, yes, they are equal, so you write the word elastic. All right, last question. You have two cars, both going north. The one in the back is going to collide with the one in the front. They couple together, and it wants to know what's their momentum and is it elastic. So first we have to find what's their common VF. So again, MAVA initial plus MBVB initial will equal MAV final plus MBV final. And just like we did earlier, factor out your VF. So MA plus MB, this side stays the same. Now divide both sides by it. So VF is equal to MAVA initial plus MBVB initial divided by MA plus MB. Okay, and then fill in your numbers. So MA was 17, was it 35? Yeah, 1735 kilograms. And 55.5 kilometers per hour, you have to switch to meters per second. And so it's 15.416, and the 6 is repeating, meters per second, plus this guy is 2540 kilograms times, and you have to do 37.7, switch it, and it is 10.472, and this 2 is repeating, meters per second, and then you're going to divide that by MA oh, I guess I should fill in the numbers, 1735 kilograms plus 2540 kilograms. And now type everything into your calculator. So times 2540 plus 1735 times the repeating, and then divided by 1735 plus 2540. So you get a velocity of 12.4789 meters per second. So the first part of the question wants to know what's the total final momentum after the collision. Okay, so for part A, it's just looking for P final. That'll be equal to the M total, because they're added together, times the final velocity. So it'll be 1735 kilograms plus the 2540 kilograms multiplied by the velocity you just found, that 12.4789 that you actually have in your calculator there. Okay, so multiply them together. So 1735 plus 2540, close my bracket, and I get 53347. 53347.36111, and that'll be kilogram meters per second. And its direction, forgot to put its direction here, would be north, and this guy's direction would be north. So that's part A. Part B wants to know, is it elastic? So you have to do 1/2 MAVA initial squared plus 1/2 MBVB initial squared. And will that equal, now on this side you could write it as MA plus MB. V final squared, because they are coupled together. So 1/2 1735 kilograms times that, what was its velocity? 15.416 repeating meters per second, and that gets squared, plus 1/2 2540 kilograms, and its velocity was, what was that? 10.472 with the 2 repeating meters per second squared. My pen is dying. Equals 1/2, and this is 1735 kilograms plus 2540 kilograms. And then you're going to multiply it by the velocity we just found up here, the 12.4789, etc. meters per second squared. Okay? So first term, 0.5 times 1735 times your speed squared. So the first term you get 206,181.8576 joules if you keep all your decimals, which I did, plus bracket 0.5 times 2540 times your speed squared, close brackets, 13,977.6466 joules. When you add this side together, you get 345,459.5042 joules. Now let's do the other side. So 1735 plus 2540, and then times 0.5 times the 12.7489, etc. squared, and that gives you 332,858.5892 joules. Okay, so even if you had rounded a little, you can still see that they're not going to be equal. Put a line through it, write the word inelastic here, and you are done. Okay, so please do questions 10 to 15 on the back side of that momentum sheet that you were working on over the weekend. And after a bit, I will post the assignment that'll be due on the day of the test, which will be either Thursday or Friday. But please do the homework questions first. Thanks, and enjoy the rest of your day.